Hi, in this video we're going to take a closer look at how convolutions and max pooling work. A convolutional neural network consists of two main parts: the convolution step, which is a process where a weighted value is calculated for each pixel, and a max pooling step that is used to reduce an image using a maximum value algorithm. Let's take a look at each of these individually. Let's take a black and white image of Carol as an example to see how a convolution is done. We will assume that Carol is just a 4x4 pixel grid. In reality, Carol is a lot more pixels, but this will work for our example. Each Carol pixel value can be represented by a value from 0 to 255, but for modeling, you can normalize all of these values to be between 0 and 1. Lighter values are closer to 0, and darker values are closer to 1. Here is where the convolution happens. A 3x3 convolution uses a weighted 3x3 grid known as the kernel. Notice that the middle of the kernel weights have higher values compared to the edges and the corners. The kernel weights are applied to each cell of the grid of a normalized pixel values. Let's look at an example and see how this applies to the green pixel value. You create a 3x3 grid with the pixel value in the center. Now you map the value to the weighted value and multiply. Starting with the upper left, you can get 0.4 times 1. You then add the next value, 0.5 times 2. You continue this in the top right corner and add 0.9 times 1. And so on. After all 9 values, you get a convoluted value of 9.7 for that pixel. Let's look at an example in the corner. Recall that you need to apply a 3x3 grid to that pixel, but in this case you don't have enough values. There are different ways of handling this. For example, you could just exclude pixels on the edges. We're going to use a process that TensorFlow refers to as same because we want our convoluted image to be the same size as our original. To use the same approach, you pad the original image with zeros to allow the edge pixels to have a 3x3 grid. Once applied, you can now calculate the convoluted values for that pixel. Using the same process, our convoluted image values can be calculated for every pixel. The second step of a convolutional model is to apply a max pooling. This is a process of reducing the image size by finding the maximum value in a smaller grid. In this example, we'll use a 2x2 max pooling. This divides your convoluted image into a new grid of 2x2 pixels. In each 2x2 grid, you find the largest value and put that value in your max pooling image grid. In the second grid of convolution values, you see that 9.6 is the highest value. The completed max pooling grid will look like this. Notice that you have now taken a 4x4 picture of Carol and reduced it to be a 2x2 grid with 4 numbers. This reduction in the image helps the model process a little bit easier, especially for larger images. Finally, a flattened layer is used. The flattened layer converts the final model data from a 2-dimensional grid to a single 1-dimensional grid in order to help the model process data better. Now it's your turn to explore.